let's identify how many functions we are looking at. How many functions are we looking at? What is the outer function? Oh, I'm sorry. What is the outer function here?
E to the power of
X. Exactly. No. The outer function is e to x. Awesome. Now, what is the inner function? Power 2. Power 2. What is the next inner function? Sine. What is the next inner function? X squared. So let's analyze this in a different way. If I want to evaluate for 5, first I determine 5 squared, then I apply sine to 5 squared and get a number, then I square that number, and then I apply e to that number. So now going backwards, because that's how we differentiate. Outer, inner, inner. So the order is 1, 2, 3, 4. So now let's differentiate in that order. F prime of x. I have to differentiate e to a function. When I differentiate e to a function, what do I have to write?
the original E.
E to that function, awesome. Times, do I have to write natural log e?
No.
No, but I have to differentiate this. So e to a function prime is e to the function times the function prime. So right here, I have to write sine squared of x squared prime. Let's do it. I have to differentiate the power first.
So 2 sine.
2 sine of x squared times the inner function prime. Now we are at number 3. We differentiated the power, we differentiated e, we differentiated the power, now we differentiate sine. What is sine prime equal to? Cosine x squared times function number 4 prime. Of course this is 2x. Yes, 2x times 2, I'll put them in front. E to sine squared x squared times sine x squared times cosine x squared. That's it. So see how important it is to identify and decompose in your mind this function. This is the outer, then I would have to square, then I would have to go to sine, and then here. If it's easier for you to identify the number of functions going backwards, that's fine. Imagine that you evaluate for 5. First you have to evaluate this. Then you have to apply sine to it. After you apply sine to it, you have to square it. When you get that number, then you have to apply e to that number. Good. So let's look at this table, because we haven't used the table before. We used other things, other values and so on and so forth. So you tell me what you would like to determine, part A or part B here. Part A is f of g of x. Part B is g of f of x. So which one? And in 69, I think, yes. Which one we want to work on? A or B?
Let's go B.
Okay. So in B we have uppercase h of x, which is g of f of x, and they're asking us to find h prime of 1. Before I even go to the table, before I even look at the table, what do I need to determine first?
Inner and outer.
Yes, inner and outer. But I'm asked to find h prime of 1. So if I ask to find h prime of 1, what do I have to give you first?
H or H prime.
Yes, H is given to us. We do not have H prime. Can anyone give us H prime?
G prime of f of x times f prime of x.
Excellent. The outer, exactly what we did here. The outer, outer, inner, inner. But we only have two here. So we differentiate the outer and then we differentiate the inner. Good. So now I can determine H prime of 1 by simply plugging in 1. So I have G prime of f of 1 times f prime of 1. And now I look at the table. Now the table is useful, not before. So let's look at the table. We want to determine f prime of 1. Can anyone give us f prime of 1 here?
4.
Yes. Everyone sees here f prime of 1 when x is 1, f prime of 1 is 4. So I will replace f prime of 1 by 4. Now I have to start with the inner. I have to find f of 1. Can anyone give us f of 1 from the table?
3.
Yes, of course. So when x is 1, f of 1 is 3. Okay, now, so far I have g prime of 3 times 4. So then I need g prime of 3. I go back to the table. Can anyone identify g prime of 3?
9.
Careful. G.
G prime of
Yeah. Yes, you're right. Yes, I was looking at G. You're right. It's 9, indeed. So now all we have to do is 4 times 9, 36. And that's it. We do have to work on a derivatives assessment. It's a file in one of the modules, and it is due Sunday, the 16th. So please start working on it immediately. You cannot, before we look at the last section. We are adding more functions here. Hyperbolic. Hyperbolic functions are 6, and of course they are inverses. I'm only interested in the first 3 hyperbolic functions. Hyperbolic sine, hyperbolic cosine, hyperbolic tangent, hyperbolic cotangent, hyperbolic secant, and hyperbolic cosecant. Yes, you can say these are trig functions. They look like, once we talk about sine, cosine, tangent, cotangent, no, they are not. They want to be called like that, but they are not trig functions. And what are they? They are combinations. So I'm going to start with sine and cosine. The rest, of course, we are using tangent, cotangent, secant, cosecant because the relationship are very close. Tangent, hyperbolic tangent is sine hyperbolic over cosine. Hyperbolic cotangent is 1 over tangent, and hyperbolic cosine over sine. All the relationships are very similar to what you know from the trig functions. But they are not trig functions. So hyperbolic sine is a ratio. It's a sum of e to the x minus e to negative x divided by 2. So what is hyperbolic sine? It's a combination of exponential functions. It's not a sine function. Okay? But the relationships here are similar to the relationships between pure sine, cosine, tangent, cotangent, and trig functions, and they gave them these names. What about cosine? Hyperbolic cosine is the same but with plus. How do they look like? And why are they so important? Where do they come from? And I want you to see a couple of figures here. This is the last section. We have to jump to it only because of these functions. So you have all the functions that we will look at. So I wanted to go back to the graphs in 311. So see, it happens that e to the x minus, where is the, I thought it was, the formula should be here. Okay, it's not, fine, never mind. So this is the way a hyperbolic sine looks like. It looks kind of like a regular sine, right? And I also wanted to show you that hyperbolic cosine, so this is e to the x minus e to negative x over 2. So it kind of looks like sine, even the graph. This is it. But look at cosine. Cosine looks pretty much like a parabola. And you can say, but who cares about this if we have the parabola? Why did they even think of this function? Well, for practical purposes, here's one very important application. You can say we're not using this anymore. All cables are underground. That's true. I agree. But when they determined for telephone, for power cables, they needed to determine the best length that they needed, between these two poles. And they took into account the weight of the cable and so on and so forth. So this is modeled by this function, which is at the base of it's a hyperbolic cosine. So that's why these functions have a lot of applications. Okay? So now the simple, so we're only going to look at these three. That's all I need. The rest you can use tables and stuff, but I want us to remember that hyperbolic sine prime is hyperbolic cosine, and here's the change, here's the only difference. Hyperbolic cosine is not minus, but plain sine, hyperbolic sine x. The tangent is the same. Hyperbolic tangent prime is the secant squared. Oh, I didn't mean it there. I want it here. I need the square after letter H, not before. Okay. So now let's look at a few applications. So we have all the necessary information, so you can start working on, you can ask questions on the derivatives assessment, but similar questions, not the questions that you have on that. Okay, so let's look at some derivatives. And we also, of course, we can play with limits as well. Limits will always follow us everywhere we go. Okay, so 35 through 53. We only choose hyperbolic sine, hyperbolic tangent, hyperbolic cosine. I don't need a secant, I don't need a cotangent, I only need the basic ones, the first three, hyperbolic sine, cosine, and tangent. So, not the inverse functions, I don't even need those. Just basic hyperbolic sine, cosine, and tangent. So let's choose. If you don't want to choose, I will.
There's like on the screen that kind of works, I think 46.
46, let's start with 46. And I think I'm on page 12, yes. 46 is a good one. So we have f of t equals 1 plus hyperbolic sine t over 1 minus hyperbolic sine t. Perfect. Can I simplify this in any way, shape, or form? Because I always want to, but, well, it's not always possible. Can I simplify this in any way, shape, or form? What do you think? Thank you for your silence. No, you're correct. We can never simplify this in any way, shape, or form. Well, if you can change this into a to maybe, but we only want to determine f prime of t. What rule applies here?
Quotient rule.
Yes, of course. I'll get it ready immediately. So I don't forget. We differentiate the top. What do we get?
Cosine H.
Yes, hyperbolic cosine t. Perfect. Minus, I copy the top, times, I differentiate the denominator. What do I get when I differentiate the denominator?
Negative cosine H.
Yes, awesome, thank you very much. Good, so now I have to distribute this to 1, this to this. The negative with the negative will cancel out, so I distribute cosine to 1. I meant t here, of course. And this to this, so plus hyperbolic sine times hyperbolic cosine. Luckily, negative sine cosine, positive sine cosine. So then the numerator is 2 hyperbolic cosine t over 1 minus hyperbolic sine t squared. And that's it. So we completed 3.1, 3.2, 3.3, 3.4, and 3.11. Of course, I don't expect you to finish this by tomorrow night, but definitely by Thursday. At least with 70%, or at least 60% if you cannot do it 70% just yet. But it is absolutely mandatory